2.5 in the calculus textbooks deals with implicit differentiation. Explicit is when it is explicitly solved for y. Implicit is when it is not explicitly solved for y. Let's start with this one. Square root of 4 minus x squared. Whether or not you know it, if you square both sides, what would you get? Y squared would equal, and if I added the x squared over, would this be basically the exact same equation? Okay, this is an equation of a circle if you don't recognize it. Yes, if I didn't, it'd have a positive negative on the square root. Okay, I'm hoping you might see that these are very similar equations. In other words, dy dx should be the same on both of them, right? So, if I was to take the derivative on the left, that would become dy dx. The square root is a 1/2 power, so you have power times the base to the 1 less power times the derivative of the base. Well, this 1/2 and this 2 are going to cancel, and you're going to have, I'm sorry, the derivative is not 2x. What is the derivative of the base? I believe it's a negative 2x, isn't it? So those could cancel. I think that would leave me with a negative x over the square root of 4 minus x squared. That's the way we're used to finding the derivative, is when it is already solved for y. In reality, you're doing implicit already. You took the derivative of the left, you took the derivative of the right, and you solved for dy dx. So that's what I'm going to do on the right. See if this makes any sense at all. Power, the power is 2. Base, 1 less power. The derivative of the base, because it's an x, you put dx dx. And anything divided by itself is 1. So I think you're comfortable with the derivative of x squared being 2x. What you may not be comfortable with is the derivative of y squared. Power times base to the 1 less power times the derivative of the base. Because of taking the derivative of y, you have to put dy dx. So basically, whenever you take the derivative of y, you put dy dx. And the derivative of a constant like 4 is 0. Can you solve this for dy dx? You would subtract 2x and then divide by 2y. So if I divide both sides by 2y, what is dy dx going to equal in simplified form? Negative x over y. So when you do implicit, your derivative might have x's and y's in the answer. Please notice this is negative x over y, right? What was y? If you were to solve it for y, would it be this? And is that the same thing we had over here? So you've kind of been doing it the whole time, except now it may not be solved for y. Let's do example 2 and a couple examples before we get into the section. Okay, I'm going to do a couple examples before we get into the assignment. This is example 2. We want to find dy dx. It says y to the third plus y to the second minus 5y minus x squared equals negative 4. I'm going to go through term by term and find the derivative. Okay, power, base, 1 less power, derivative of the base. Because it's a y, I put dy dx. Power base, 1 less power, times the derivative of the base. Because it's a y, I put dy dx. The derivative of 5x or 5y is 5, but I also have to take it times the derivative of y, which is dy dx. power base, 1 less power derivative of base. This time the derivative of base is dx dx. I took the derivative of x, I write dx dx. And the derivative of a constant like -4 is 0. I took the derivative of each term, term by term. Okay, you may notice that these three terms have dy dx. This one does not. So I'm going to take the one that does not have dy dx and add it to the other side. So I move 2x to the other side. Every term that remains on the left now has dy dx in it. Factor dy dx out. 3y squared plus 2y minus 5. Now, if I want to solve for dy dx, what's the opposite of multiplying? Dividing. So dy dx would equal 2x over 3y squared plus 2y minus 5. And that's the answer for example 2. Okay, after example 2, I made up one here that had a product. So let's take the derivative term by term. Power base, 1 less power derivative of the base. Because it's a y, I put dy dx. Now I see a product. Okay, I kept the -3 out as a constant, which gives me a product, which means I need to do the product rule. I'll bring the x squared down times the derivative of y, which is dy dx. Plus, this time I'll bring the y down times the derivative of x squared, which is power base, 1 less power derivative of base. Because it's an x, you put dx dx. The derivative of 7x is 7 times the derivative of x, which is dx dx, which makes it just 7. Yes, I did a product rule on x squared times y. Now I'm going to distribute the -3 and try to clean this thing up. If I distribute this -3, I'd have -3x squared times dy dx. This would have, when I distribute over here, I think it's a -6xy, and it's going to equal 7. Take the terms that do not have dy dx and move them to the other side. So I'm going to add 6xy. Now both terms that remain have a dy dx. On the right, I have 7 plus 6xy. Can I factor the dy dx out on the left? That would leave me with 2y minus 3x squared. And on the right, I would have the same thing. Again, the opposite of multiplying here would be to divide. So if I divided to find dy dx, I'd have 7 plus 6xy, all divided by 2y minus 3x squared. Now that was an example I just created or made up because it had a product in there. I wanted to do one that had a product. This next one, example 7 here, wants us to find the second derivative. I hope everybody watches because there's one key step at the end. So, first find first derivative. So I do power base, 1 less power derivative of base. Because it's an x, I put dx dx. Power base, 1 less power derivative of base. Because it's a y, I put dy dx. And the derivative of a constant is 0. So if I was to solve this for dy dx, I'd have to subtract the 2x and then divide by 2y. So I think we might have done one like this earlier. You get -x over y. Now I'm going to box it in, even though that's not the answer they want. We want the second derivative. That's the first derivative. But I'm going to hesitate a moment. Okay, I have the first derivative. I need to get to the second. So to find the second derivative, you take the derivative of the derivative. It's written a little weird, so you need to get used to this notation. d2y. The 2 is on the d because it's the second derivative. dx2. This time the 2 is on the x because it's both times with respect to x. Because this is a quotient, I may keep the negative out front as a constant. So basically I have a quotient of y over x. So I'm going to do a quotient rule. The bottom times the derivative of the top, which is just dx dx, minus the top times the derivative of the bottom, because it's y, you put dy dx, all over the bottom squared. So what does that mean the second derivative is so far? I haven't simplified. Y minus x dy dx all over y squared. So I'm taking the derivative of the derivative to make it into the second derivative. Now, here's the thing that a lot of people don't notice, or one of the things people don't notice is you can't leave dy dx in it. Is there something I might be able to replace dy dx with? So I'm going to replace the dy dx here with negative x over y, and then I'll try to clean this up. You are absolutely correct. There is a negative in front of all this that I just forgot about, and there is a negative in front. So this would become negative y minus x squared over y all over y squared. Again, I'll never take a fraction within a fraction, so opposite of dividing by y would be to multiply by y. So I do it over here. Y times y becomes y squared. I multiply here, and I get minus x squared, and it's all over y to the third. What most people fail to notice is the second derivative will almost always contain some form of the original. If I take a negative out of what I have circled, if I take the negative out, because I think, did I put the negative in? Yes, I did. Okay, if I take the negative out, what would remain? Would it be x squared plus y squared? Yes? And what is x squared plus y squared? X squared plus y squared from the very original is 25. So what happens is, in the second derivative usually contains some form of the original. Okay, here's an example of a question that you're going to run into in section 2.6. This is called a related rate question, where the rate of one thing relates to the rate of another event. In this case, if you read this question very carefully and draw a picture, you have a 13-foot ladder leaning on a house. If the bottom is pulled away from the house at 3 feet per second, how fast would the top of the ladder be moving down the wall when the base is 5 feet from the wall? Now, I said the base is changing, so I have to give it a variable. I tend to give horizontal lengths x and vertical lengths y. Yes, x is 5, but only for an instant, right? If the base is being pulled out, that length is changing, so I can't use a constant. Okay, since I have these two lengths being variables and the 13-foot being constant, I could probably write Pythagorean theorem. X squared plus y squared equals 13 squared. Take the derivative, power base, one less power, but this time in 2.6 you have to do it with respect to time. So you have to put dx dt. Power base, one less power, derivative of base, because it's a y, you put dy dt. And the derivative of a constant is x. I'm doing this problem now to show you that if you don't write dx dx, you're probably not going to write dx dt. So please don't take too many shortcuts in 2.5, or ones like this in 2.6 are going to get challenging. So what I would do is realize 3 feet per second, guys, please listen, is how fast what's changing. That's how fast x is changing. So that's dx dt. Is x getting bigger or smaller, increasing or decreasing? So that means it's increasing, so it should be positive. They want to know how fast it's moving down the wall. So they want us to find dy dt. Is y's length increasing or decreasing? So I should expect dy dt to be negative because y is decreasing. So what I'm going to do is I think I'm going to fill everything in and solve for dy dt. It says at the instant the base is 5 feet from the wall. So x would be 5. Do we know dx dt is 3? I know that because that's how fast the base is going. I don't know if you're aware, but this is a 5, 12, 13 right triangle. You could use Pythagorean theorem if needed. So you get 12 for that length. Solving it for dy dt, you would subtract, I believe, 30 and divide by 2 times 12, which is 24. 6 goes into 35 times, 6 goes into 24 4 times, and that would be in feet per second. I can tell you on the AP test, you get 1 point alone for the unit. So even if you can't do the problem, make sure you at least put the units. Anyway, again, this is 2.6. I'm just trying to illustrate why it's important to put dx dx. Let's go back to 2.5 and look at some questions from the assignment. Okay, your assignment in 2.5 is going to be 1 to 17 odds, 23, 25, 41, 43, 49, and 51. That gives you a couple of tangent line questions and a couple of second derivative questions. So, number 1, I think we've done already, but let's do it again. Power base, 1 less power derivative of base, which because it's an x, you put dx dx. Power base, 1 less power derivative of base, because it's a y, you put dy dx. The derivative of a constant like 9 is 0. So to solve for dy dx, I would subtract the 2x, and then I would divide by the 2y, and I would get dy dx to equal negative x over y. I think we've done ones like this before. Now number 3, I would do power base 1 less power derivative of base. Because it's an x, you put dx dx. Power base 1 less power, because it's a derivative of the base, because it's a y, you put dy dx. And the derivative of a constant is 0. So this is 1 over 2 radical x plus 1 over 2 radical y dy dx equals 0. I would subtract the 1 over 2 radical x, 1 over 2 radical x, leaving me 1 over 2 radical y times dy dx equals negative 1 over 2 radical x. To solve this for dy dx, I might have to multiply by the reciprocal, or multiply by 2 radical y over 1, 2 radical y over 1. I think the 2's would cancel, leaving me dy dx to be negative radical y over radical x, or maybe the big fraction, big radical, negative radical y over x that way. Okay, we've done 1, we've done 3. Let's take a look at 5. I want to point something out. Because wherever there is a product, I leave a space. Do you see how I left the bigger space? Because I have to do a product rule. Same thing here. Do you notice I left a space here because I have to do a product rule? I'm just pointing out, sometimes if you leave yourself a little bit of room for product rules, you'll be a little better off. Okay, here's 1 and 3. 5, like I say, I left space for the product rule. Power base, 1 less power derivative of base. Because it's an x, I put dx dx. I think I'll keep the negative out front and simply do a product rule on x times y. Okay, apparently it's x cubed. So what would be the derivative of x cubed? Power base, 1 less power derivative of base. But I am going to do a product rule on x times y and keep the negative out front. It's a good idea to keep constants out. Product rule, please listen. I'm going to bring the x down times the derivative of y, which is dy dx, plus bring the y down times the derivative of x, which is dx dx. Anything divided by itself is 1. Derivative of y squared, power base, 1 less power derivative of base, and the derivative of a constant such as 7 is 0. So I just need to clean this up a little bit. So I'm going to clean this up now. This would just be 3x squared minus x times dy dx minus y plus 2y dy dx equals 0. Now I'm telling you that with practice you'll get pretty good at this. I don't know. It doesn't really matter. I've been telling you to move the ones that do not have dy dx to the other side. So that means I would add y and subtract 3x squared. Add y and subtract 3x squared. That would move all the terms that do not have dy dx to the right. The two that remain should have dy dx in them. With practice, you'll be able to factor it out about that easy because there's a positive 2y and a negative x. And again, the opposite of multiplying here would be to divide. Remember, you're trying to get dy dx by itself. So you have y minus 3x squared, and you're going to divide this by 2y minus x. Yes, there are other answers. It could be 3x squared minus y over x minus 2y, depending upon which side you brought your dy dx's to. If I left my dy dx's on the left, so I got this first answer. If you had moved your dy dx's to the right, you might have gotten the second answer, but they are equivalent. Okay, after 5, I think we got 7. Again, this is a product rule, so I left myself some space. So I'll bring down x to the third times the derivative of y to the third. Power base, 1 less power derivative of base. Because it's a y, you put dy dx. This time, bring down y to the third times the derivative of x to the third is 3x squared times dx dx. Apparently, I did not leave myself enough space here because I was trying to keep it lined up. Now, that all right here is my product rule. Dx dx is a 1. Minus the derivative of y, where you put dy dx, equals the derivative of x, which is dx dx, and that dx dx becomes a 1. So let's clean this up, put it in alphabetical order. 3x cubed y squared dy dx plus 3x squared y cubed. Now the only minus dy dx. Now I'm just going to subtract 3x squared y cubed over. Subtract 3x squared y cubed over because it does not have a dy dx. And that gives me this. Now notice what remains is this and this. With practice, you're going to get good at factoring dy dx out. If I take it out, I'd have 3x cubed y squared minus 1. If you distribute, you'd get what's circled in orange there. Now again, the opposite of multiplying is to divide. So dy dx is going to be 1 minus 3x squared y cubed over 3x cubed y squared minus 1. Now I kept the dy dx on the left. If I had happened to move the dy dx to the right, I would have gotten this equivalent answer. And again, like I say, they are equivalent. On a multiple choice test, you're only going to have one of those as an option. So it'd be nice if you knew that they were equivalent. After 7, I'm going to jump to 23. That's a second derivative. We did one like this in the example. Because we did one like that in the example, I'm going to do the tangent line real fast. I have a point. To write an equation of a tangent line, you need a point and its slope. The slope is dy dx at that point. So I need to find dy dx. I'll keep the 4 out as a constant and do a product rule. X times the derivative of y plus y times the derivative of x. And that derivative of a constant would be 0. So you could divide by 4. 0 divided by 4 is 0. So you have x dy dx plus y equals 0. Solve it for dy dx by subtracting y and dividing x. Now at this point, I have an x and a y. In place of the y, I put 9/4. In place of the x, I put a 1. What does that make my slope? Negative 9/4. So at this point, I'm going to fill it into it because I have a point and a slope. I'm going to use point-slope form. Y minus the y value is equal to m times x minus the x value. And then I'll just fill in what I need. Y minus the y value is 9/4. The slope is negative 9/4, and the x is 1. Usually you have to solve these for y. So if I solve this for y, I'd have negative 9/4 x plus 9/4. Add another 9/4 to that 9/4 makes 18/4 or 9/2. And that would be your equation of the tangent line to this curve at the given point. I hope these help. Good luck.